Hi, I'm Jan Borch, IoT System Architect and part of the European IoT Competence Center. And I will be your host today for this webinar about IoT data case studies, handling large stream of data. Now, before diving deep on AWS IoT, I would like to show you two interesting projects that I found on the internet about getting insight out of large data sets. I suppose I won't teach you anything new by telling you that data is gold, but in this case, it might even save lives. The University of California runs a project called eHeart study. They use heart rate measured by smartwatches to detect heart anomalies. Now, interestingly, they can onboard easily a new test person by just asking people to install the smartphone app. Having access to a large amount of test person make it possible to detect trends and patterns across the test population. A second example I've personally found quite interesting is this one. Researchers analyzed a large data set of taxi trips, and they found correlation between tipping behavior and average speed of traveling. Now, looking at the first part of the chart, I think it's quite obvious that you tip less when you're stuck in a traffic jam. But what about why does the tipping goes down after 50 miles per hour average speed? So when you're in fact going faster. So in these two examples, it's really fascinating what kind of insight you can get out of if you're crunching large data sets. Now, what do both of these examples what do they have in common? They all collect data from connected things. Smartwatch in one side and taxis in the other side. Connected things give you a tremendous opportunity to collect data. And today I will show you several use cases I worked or my team worked on where large scale of data was collected, but also give you a quick overview of the building blocks of an IoT solution. Analytic is one part of the coin. Connecting things in a scalable, cost-effective, and secure way is another side. Now, as a member of the EMEA IoT Competence Center, I already worked with customers across many different industries, from connected home, embedded vision in retail, smart cities, several industry use cases from engine maintenance to electric power control, and the list goes on. Now, this industry collected telemetry data before the ways of IoT. Now, but IoT platforms like AWS IoT made it easy to collect metrics from millions of devices in a secure and scalable way. To solve business problems and technical problems like this, smart building, on predictive maintenance, fleet management, high-value asset tracking, industrial equipment monitoring, or in the insurance telematics. Now, so in the remaining part of this webinar, I will show you some examples we worked on. Talking about large data sets, Philips use case clearly is on the top of the chart, with 15 petabyte of data stored in Amazon Web Services and analyzed. Here, IoT was used for device management, and Philips worked closely with our team, in fact, to shape, in fact, the state of the current IoT service. Enel, utility company based out of Italy and world leading integrated energy and gas operator, worked with Amazon Web Services on a smart metering project. Now here the number of things is worth mentioning. We talk about millions of smart meters sending consumption data to the AWS cloud. Another example out of the consumer world. When you talk about consumer market, the numbers of devices grow exponentially. iRobot sold, for example, 15 million connected vacuum cleaners. iRobots. Here, of course, having an IoT platform that scales with your success is invaluable. Talking about scale, we're taking Amazon as an example. So Amazon use robots in their warehouses to move shelves to the packaging station. Now, if we build apps that monitor a single robot, we would have quite a bit of challenges, in fact, managing all these robots and the logistic operations. So Amazon needs to monitor hundreds of thousands of these robots across different fulfillment centers globally. Another example here is in Europe. We partnered with Audi and DHL to deliver packages to the trunk of the cars. Now here, the delivery person can open the trunk once with a mobile app, and then the owner gets notified that the parcel has been delivered. And the last example is one that our team personally worked on, and it's a European gas distribution company. Now here the difficulty was the distributed nature of the things to monitor. The things to monitor were gas tanks, and they wanted to measure the pressure of these tanks and detect problems from the maintenance perspective if the pressure lowered accidentally. Now, here low energy, low bandwidth, and large range protocols like LoRaWAN and Sigfox were important because of the distributed nature of these gas tanks across Europe. This is the predictive maintenance case. Now, in the previous example, we highlighted some of the challenges and use cases we've seen across our customer base. But to summarize, these are the main challenges customer told us. So there is many different SDKs and tools you have to integrate it on your devices. There's a variety of protocols. Once you reach millions of devices, scalability and managing scalability on your backend is a real challenge. Security and management of devices is key. Without security, you don't even start your IT project. And of course, you want to do something with the cloud, integration with cloud and mobile applications. So out of this necessity, we identified 3 pillars of each IoT solution. In fact, the acronym IoT should have different meanings. I for intelligence, O for cloud orchestration, and T for things. Let's zoom in on the cloud orchestration part and highlight the main components of the AWS IoT solution. So AWS IoT is a platform that enables you to securely connect devices. This is the authentication authorization component on this diagram. Once connected, you need to ingest data securely and interact with it. So this is the device gateway and registry component on this diagram. You need to process and act upon device data. So there's a rule engine that you can configure, in fact, to act on your data. You want to enable application to interact with devices even when they're offline. So the AWS IoT has a concept of a device state or shadow that can be used, in fact, by application to interact with the device state even when the device is disconnected. And of course, AWS IoT is not an island, it's fully integrated with other AWS services. For example, with the action component of the rule engine that has built-in integration with a lot of AWS services like databases, real-time analytics, and machine learning components. But it doesn't stop here. I just talk about integration with services. What's the next step? Once you have ingested device data in a scalable, low-cost, low latency, and reliable and in a simple way. Now you can use the full ecosystem of AWS services to act upon your data. So first, of course, storing or archiving your data in one of our storage services to create your data lake. Data streaming services to perform real-time analytics. Processing your code with arbitrary programming languages in a serverless approach. slicing and dicing your data and visualizing your data, prediction, artificial intelligence and machine learning, and finally, of course, storing this data in your traditional data warehouse. All of this can be done on the Amazon Web Service platform. One of the example I want to highlight in here is an European electricity producer specialized in renewable energy. Here we use the AWS IoT platform and multiple Amazon Web Service components to create this solution, like DynamoDB, Lambda, and API Gateway. So here, the problem was that traditional SCADA-based control and monitoring systems are costly and not flexible enough to manage this highly distributed small energy producer like windmills and solar panels. Now, using AWS IoT connected PLC deployed at the power producing facilities, the customer was able to control and monitor the power production and storage in a cost-effective and scalable way. Now, this is not all. Most machine data never reaches the cloud for different reasons. Could be economic reason. The cost of bandwidth is not falling as fast as the cost of storage and compute. So you may need tools for locally aggregating and filtering data. So making it easy to act on lower value data locally and uploading high value data in an aggregated form to the cloud for analytic and storage. The other problem is latency and last mile connectivity. So latency to the cloud can be unacceptable for scenarios like that need timely automated decision making, like crash avoidance, medical alerts, or physically remote operating environments like mining sites. Now, especially in conjunction with wide area wireless networks such as cellular. So some of the decision making must continue to be executed locally on the device. High value and safety critical processes must also continue to work when the internet connection is down. Now, the third reason is compliance and privacy. For legal or compliance reasons, a concern around privacy, some industry prefer to store or duplicate some data locally. For example, hospitals, or even for governments that impose data sovereignty restriction on where the data may need to be stored. So I want to talk a little bit on the sync side. And here, to solve these three kind of restrictions, AWS Greengrass is one of the product that brings local compute messaging and caching and synchronization features to connected devices at the edge. So AWS Greengrass works almost on any devices with general purpose CPU that run Linux and supports ARM and x86 architecture. And now, why do we need this? Here's a good example. For here, to manage a fleet of trucks for the mining industry. Here, the local processing is an important aspect, and maybe later on, if you want to, for example, do cameras with computer vision algorithm, this is also something you might want to process locally. Another example in the predictive maintenance area are, for example, industry components like water pumps. They might be installed in very far located locations, maybe middle of the jungle, with intermittent connectivity. So to accurately detect anomalies in such a pump based on vibration sensors, you need a sampling of 100 Hz, so 1000 events per second. Now, this would be extremely difficult to send up to the cloud over this low bandwidth connection. So applying algorithm at the edge with Greengrass, for example, to detect maybe the 5 largest harmonies in the vibration signal, And only sending this information to the cloud will drastically reduce the amount of data you push to the cloud. So here again, Greengrass is a perfect candidate here to do analytic at the edge. Now let's move to the last pillar, intelligence, and talk about data analytics and artificial intelligence services and application services. So AWS IoT comes with built-in dashboarding capabilities, but you're not limited to these. For these three domains, you can leverage the full extent of the AWS IoT building blocks. And the next slides will go a little bit deeper into these domains. So, big data and analytics. Once you have ingested your data on the IoT platform, you can use multiple tools at Amazon Web Services to process your data. For example, Athena, it's a serverless interactive query service that makes it easy to analyze data stored on Amazon S3 using standard SQL. Amazon EMR, our managed Hadoop service. Amazon Kinesis to do real-time analytic on an event stream. And of course, Amazon Redshift, our petabyte scaled data warehouse solution. Artificial intelligence services. Here we offer out-of-the-box solutions like Amazon Lex for conversational kind of interfaces, Amazon Machine Learning for running your predictive or linear regression kind of algorithm, Amazon Poly for text-to-speech, and Amazon Recognition for image recognition. Applications. Building application on the Amazon Web Service Cloud is easy, and we have a lot of services and components that can help you here. From managed API gateways to our AWS Lambda functions to caching and NoSQL databases like Amazon DynamoDB and Elastic Cache. And again, as an example here, I want to highlight one of the engagement we had for an industrial floor manufacturer. They produce connected industry floors and had the goal to detect people's activity by analyzing pressure-sensitive floor tiles. But not only like simple activity like people falling on the ground, they also wanted to correlate this data with other data like the time of the day or other ones. For example, triggering an alarm when the walking behavior changes and it's maybe middle of the night and the patient took a certain medicine. So another use case we could add to this thing would be like voice recognition. For example, by analyzing the speech and the emotion stress level that is in your speech and alerting the personnel when stress level is detected in your voice. So let's go look a little bit deeper into these AI services I mentioned before. So of course we have the whole Alexa ecosystem. And you as a developer, you can extend these capabilities of the Alexa device by creating your own skills. But not only this, if you are a manufacturer of devices, and you can even integrate voice capabilities into your devices with the Alexa voice services. Amazon Lex. Now, human-machine interaction is an important aspect of IoT. AWS offers a service that can quickly create conversational interfaces to your application, powered by the same deep learning technology as Alexa. And this service is called Amazon Lex. And Amazon Poly is the counterpart. It's a powerful text-to-speech service you can also integrate into your app easily. Image recognition, another important topic. AWS recognition can help you identifying objects in images, identifying faces, and much more. And again, easy to integrate using the Amazon Recognition API. And if some of these managed or pre-built AI services don't offer what you need, you can build your own deep learning model using Apache MXNet. Now, MXNet is an open source deep learning framework, and Amazon Web Services is a key contributor. And in fact, we offer a template to quickly start up a state-of-the-art deep learning development environment in the cloud in minutes. And you're not only limited to one server. If you need more compute capacity, you can extend it to a kind of real deep learning cluster. On the application side, the easiest way to start is our AWS IoT button. So IoT button is a Wi-Fi enabled device that can connect to Amazon Web Services, allowing a click of the button to initiate service in the cloud, like triggering a Lambda function, sending an SMS message or an email. So just go to amazon.de, order your IoT button and get started. Additionally, we also offer a mobile app to get you started even quicker. You can register, configure, and program simple blueprints in 1 or 2 minutes. And here, an example of ordering beer. My course in the US created a replenishing button where if you run out of beer at home, you just click the button and the delivery service will get you some beer to your house. So just get started. Take a look at Amazon.de, search for the AWS iButton second generation. It's $24.99 US. Download the app and start building your end-to-end IT solutions. So to conclude this webinar, I wanted to showcase one of the project I was personally involved in. It's a predictive maintenance project with Wärtsilä, a vessel engine manufacturer based in Oslo. And here we work together with Accenture and Salesforce. So the situation here was that Wärtsilä builds vessel engine and sells them to vessel manufacturer, but they also sell support and maintenance service for the engines. Now, maintenance on sea is quite expensive and it's difficult to perform. Now, it's much easier, of course, when the vessel or the boat, the ship is on a dry dock or in a harbor. So Wärtsilä needed an easy way to predict the maintenance window to plan this intervention. So in the first phase, they used, in fact, near real-time geolocation feed from a third-party vendor, ingested over IoT to create a prediction model about the maintenance schedule of all their vessels and engines. This was stored in Salesforce and managed in Salesforce. In the second iteration, this in fact gave already a good approximation of the maintenance window. Now in the second phase, they realized that there are other factors that influence the energy efficiency of ship. For example, if the hull is damaged, the ship engine needs to power much more to reach the same speed. And this also has impact on the maintenance window. So in the second phase, what we will do is also improve the prediction model by taking into account near real-time engine metrics. So the simple dashboard we created for this engagement is shown here, where Wärtsilä was able, in fact, to monitor their vessels on a map and got all the metrics like the engine running hours, the next prediction maintenance date, the engine state information in a highly visible and direct accessible dashboard for planification of their maintenance schedules. So on this, I want to conclude this webinar session. I hope I gave you some ideas on how to use our IoT platform to collect data and all the services, big data and analytics services to reason on it. I hope to welcome you on our next IoT Web Day. Bye-bye.